Okay, 34 degrees last night in the outside, about 50 this morning in the garage. And I'm going to show you my overboard diesel heater setup. This is my third generation of these. Looks like a spaghetti monster on the outside of the house, but it's actually pretty cool. I've learned a ton, and I want to share a little bit of that advice. This will be kind of targeted towards what's inside my diesel heaters, I suppose. So not for everybody, but definitely if you have diesel heaters or you're thinking of them, they are a lot of fun. Currently running, so hopefully you can hear this pretty well. The big secret sauce here is that manifold. We'll hit that up in a few minutes here. Second secret sauce is there's diesel heater 1, diesel heater 2, and I have two of them because 18,000 BTUs or 15,000 or whatever the exact number is on one isn't quite enough for a 26 by 26 garage, especially when it's 10 degrees out. It can sort of maintain, but it can't quite hold up with it. So let's see, the best way to do this, everybody wants to see that manifold, and that is seriously the secret sauce to the whole thing. That was learning number one. So on Gen 3, I'll show you the Gen 2 shortly after this, but we'll just start at the fuel supply. This year I've gone to 2 independent fuel cans, both with taps. This was a $35 one, it came with a gray cap. I was like, oh, that's pretty cool. But turns out the $15 one, which I'll try to put links in there for you, works as well with a Midwest diesel can here. So my goal this year was to get the fuel away from the heaters. And secondly, for me, you can see I got my patio that ends here. So I just sort of got it on the patio so I don't have to get my feet wet when the snow comes and I shovel off the patio. I can just come out here and change a fuel can. I got 5 gallons running at a time. Also, I put them up on this runner here, and the whole reason for the runner is to keep the fuel supply up so that if a line gets severed, the fuel line doesn't fall on the ground and then have a pre-primed siphon all the fuel out, and I end up with 5 gallons of fuel on the lawn. So that's that component of it. In addition, on the fuel supply, I'll show you this one with a label, but actually I'll just show you this one here. I got these, I'll put a link to that as well. You drill a hole in the can and you put it in from the outside. No tools required on the inside of the can, but I had to put these on so that when it rains I don't leave the cap loose, but I leave the cap to the vent loose. But the way it's designed, it rains on the can, you don't get a lot of water in there, and then this cap stays tight. If you don't vent it, the can eventually compresses and inward from the vacuum. I'll probably shut the heater down. They come with these nice fuel supply kits that have filters, so the fuel is filtered, which is nice. Runs over here, hits a valve. The valves are actually on the heaters, so I'll probably rethink that. If I have a Rev 4, I'll probably stick the valves over here somewhere on top of the post, but that's the way it is for now. Fuel supply runs in my case, so it comes in, it runs in the case, runs around, hits the pump, goes down to the heater. In the Gen 3, one thing I wanted to fix here was having this cutout here so I can easily inspect for fuel leaks. That's sort of what the box is there for as well. Come around here. So for each heater, it's got heat coming out. So the heat comes out this metal tube so it doesn't smell. Goes into the manifold. I've got these neat connectors, and I have a return line of air, and it comes through, hits this, comes around, and then hits this adapter that I 3D printed. I got that off probably Thingiverse, and I'll put a link to that as well in the show notes. And then it sucks air in, so when it's 10 degrees out, I'm not bringing 10 degree air in, or air that has smell in it. I'm just doing a round trip of like maybe 50, 60 degree air comes down this tube. Might lose some heat along the way, but at least it's entering and then comes out a lot warmer. So that's pretty cool. Let me see, from a wiring standpoint on the outside, I just have these chases coming out. So I have 12 volts in one wire, and I have an extension cable for the control wires. So this extension cable here means that I can run the control head inside at 100% without having to use a remote control. And then of course just 12 volts in. And the reason I put 12 volts in is I can run the power supplies of my choice from inside, whether it be a battery or something else. I don't have to come out and muck with them. So we have heater 1, and we have heater 2. And this one you can see I got a few air bubbles in there, but I haven't been able to track that down. It doesn't seem to have any operational impact on it. Same exact design. So that's pretty cool. And then finally, on the outside here, my diesel heater. It is running right now, so hopefully you'll be able to hear all this. These exhausts get extraordinarily hot. And so I put a bend, probably can't see that, but I have a bend in the exhaust so that it doesn't line up. It doesn't line up with this fuel supply here, if you can see that. So it doesn't line up, and so if the fuel supply starts to leak at this junction, it'll drip on the box and not hit the pipe below. And of course the air intake is below as well. So that is the outside. Not sure my wife fully approves of it, but I love the heat coming in my garage. So I made 2 boxes. So let's go on the inside, and then I'm going to tell you about Gen 2 here in a few minutes. So as I mentioned, the manifold really is the secret sauce here. You can see I have 4 of these plastic adapters. I'll put them in the show notes. You get them off Amazon, about $5 a piece. And I put this track in, 3D printed a track at the top and the bottom. So it's a solid piece of wood. It won't move if the wind is blowing. And it allows me to interface into the house. I can feed the cables through. I printed these plastic adapters. I might put them on Thingiverse, so if you have interest in those, I can get you the models for them printed on a bamboo 3D printer. Here it is all kind of in assembly here. So we've got those covers in there. I've got some return lines. Again, it's a little bit different configuration what I'm actually using it for right now, but those returns are fantastic. Cut those out, little cable chase, and again, just a solid piece of wood to interface into your house to keep the wind out. And I think that's really the secret sauce. If you're gonna put it in a garage or something, is get that diesel heater outside and just run a hose, even if it's just up to 1 port. Just get 1 port of heat coming in your house, and maybe that's all you need. So the final thing is I did print custom flanges, just basically U channels. As wide as my printer could go on each one, but I made a top and bottom chase designed to fit that plywood. So it holds it in there super, super secure. So yeah, that chase is the one that fits on the lower, and then we've got the uppers here, and they fit in that window too. And just holds it super, super secure, which is completely awesome. Before it used to kind of blow with the wind. If the wind was blowing too hard, it could blow the manifold out of its position and leak air. So now that no longer happens. It just couldn't be more tickled pink. Covers when they're not in use on the inside and the outside. And no way for air to flow through. Then I'm going to tell you about Gen 2, which is the old one, which is sitting here from last season. I'll tell you why I upgraded to this Gen 3. I call them Gen 3s. So here we are. Heat's coming out of here. About 205 degrees right now. I have a little monitor here. About 200 degrees. This monitor will alert me if things get too hot. That's a whole different project. That's the temperature probe there, just in the airstream. So we have a 199 coming in, 205 of just clean, warm heat. And then these are the return lines. So this is where the heat goes back. I will say that if I were going to build a Gen 4, I'd probably also try to figure out how to use 4-inch pipes, because when you take the heat out, it's great, but when you actually have the return line, there's a lot of air friction in there, going all the way into the heater and around. So Yeah, I'd probably try to upgrade to 4 inches just to reduce the air friction in there. And then I put these on top of the box just so you could really see what's going on. But let's just start from AC out. This is the power. I ended up with an echo flow to run these, because if you shut them down hard, the electronics package is actually in the heater box with the heat airflow. So I've heard people cooking their controllers, so I just wanted a way to gracefully shut down. Originally, that's why the 12 volts is inside, because I was going to run the batteries. I was going to run it off a big car battery or something, but in the end, the echo flow actually worked out a lot better for me. So I'm really pleased with it. So I just have a way to, I have like an hour to come in and just gracefully turn it off if the power goes out. I can shut each heater down and not exceed the max specs. So AC comes out of the box, comes into, we'll follow the one on the right. We got a right and a left. The right one comes into its own power supply, cheap China power supply with SAE connectors on it. And then it goes into this little box. It's just kind of a current monitor that's more for me. And then it follows out, it goes out here through the exit port. So AC in, ultimately 12 volts all the way out to the heater, and that is how you start it up. Remember, these things take about 10 to 15 amps in startup, so a lot of juice. The other wire is just a big long extension cord that I purchased online for like really cheap. I'll try to find that, see if they're still available. But these extension cords then allow you to run the control head right here. So you can see, what can I see here? I don't know what that's doing. But you can see this control head is actually running this unit. So I have the real control head, I don't have the fake. And then if you come over here to the left side, it's really just the exact same thing. 2 wires coming out, trying to avoid the hot leads, right? With the control wires coming in. And again, I've got this kind of laid out to make it logically make sense. So it comes from the echo flow, comes around, hits a 12 volt power supply, 12 volts out, I can monitor it, 12 volts out to the unit. And then on the way back in, I'm running the actual control head that came with the heater. I stripped them apart, put them in the box. So this isn't a how to build, this is more of a just show you what I got going on. All right, so that is sort of it in a nutshell. And then in addition, you'll see I've got these temperature probes. I built this box, it runs on a Pico, so it has lights that tell me I'm in my safe operating range. I'm getting over 208, so it gave me a warning there. 208 comes up when it hits so it's flap around, but eventually if it gets too hot, hits a red, it sends me a message and alerts me on my Apple Watch, so that's pretty cool. So I know what's going on, gets itself an IP. That's the actual Wi-Fi signal strength there, so that's pretty cool. And then if you come over here, I'm actually running that whole unit on an independent power supply, so that if there were a problem and the echo flow or something caused a bigger problem, I would be able to be alerted independently of it. So that's kind of what that whole unit is, because I'm not always in the garage, but I want to be careful. Let's talk about the Gen 2 and why I moved to Gen 3. So let's just start with Gen 2. Gen 2 is right here. I built this and used it all last season, worked great. The problems that I had with it are, well, let's just start with what it does. And then we'll go back to what it fixed, why I went to another generation of heater design altogether. So this is the Generation 2 for me. So air intakes are here. They just happen to have these covers that I printed out on here. Ambitious. I'll put it up on Thingiverse, or if somebody requests it, I'll get it in place so you can download the STL files, print your own covers. But air returns came out in the middle. They still use that same manifold on the window. They came into the heater. They came into the heater. Looks great so far. 12 volt power came in. Extension cables connected here. Air out here from each heater. Just happened to be covered. And that was kind of it. And a cable chase right here for the cables to come in. And so it worked great. So the problems I needed to fix were, number one, inside of this huge metal wood box were 2 diesel heaters running, 1.2 gallons, 1.2 gallons. So I had about 2.5 gallons of diesel fuel when I was filled up inside the box. So if there was a major malfunction and these caught fire next to my house, it would create a huge effing fire. So I didn't like that. And then I was all season long, I'd have to come out, check them, walk all the way over, get my feet wet or whatever, not a big deal. And then I was always pouring fuel from, to refill them. So I'd have to come out and have to pour 1.5 gallons into here from the big yellow cans, 1.5 gallons here from the big yellow cans. So first step was get rid of the fuel supply from inside of Gen 2. And so Gen 3, as you saw, has my fuel supply 6 feet away on a platform that I can get to, and I never have to pour the fuel once I brought it home from the station. So I fill it at the station and I'm done. So I take away a whole bunch of risk of filling and also maintaining and then burning the heaters. So if something happens to the heater box, and once the fuel supply is cut off, there's no more fuel other than the wood of the box to burn and some plastic. So it's a much better situation. So that was number one. Number two issue that I was trying to fix was that these are actually independent units, right? You just buy them, and I was like, oh, I'll just put them in. However, in order to take a unit out, because I've got them screwed in, I had to take the side of the box off, and to get to that access point, to disconnect the exhaust hose and the air intake hose. And so I'd have to do that in order to pull it out. Not only would I have to take that off, if I wanted to fix this heater, because the access panels were on this side of it, you can see the little slot there to get to the access, I would have to take this heater off first to get to this heater. And it's 10 degrees out and the wind is blowing, and the whole point of these is not to have that. So that was problem number, what am I on? 2, 3, a lot of problems here. So great design in concept. The next problem that I had was that if I wanted to fix it, number one, I'd be fixing it in a cold garage because I wouldn't have a heater running and I'd have to pull the whole box in. Well, this box is too big for me to move on my own. It's just gargantuan. So great idea, but it was just too big for me to move on my own. So diesel heater 3.0 are modular. They're independent units. I can just shut one down, detach the hoses, detach the fuel supply, walk into the house, carry it in, fix whatever I have. I can get to everything because it's just a heater. It's literally a heater and a fuel pump on the inside of that box. So I can bring the whole box in, work on it while I have one heater still operational. I guess the goal would be to have a third Gen 3 unit as a spare, but I have the innards of these to go with. You see, what is another problem? Not only was this thing huge, the exhausts were huge. I wrapped them. I had to put them in. Just a much harder maintenance story. And then, of course, since the fuel supply is inside of these units, in each one of these units, even then I couldn't tip them on their side without draining fuel. So it really comes down to portability of an individual unit and then the fuel supply situation. So when I'm over here, I get 5 gallons of runtime now. I don't even have to think about it for at least a week, even on the coldest days. So I have portability, easy repairability of the units, and I never have to pour fuel again. I just fill it up at the station, bring it home. I have a spare can, and I'll just insert it in, pull the lid, plop it in, and then I'm done. That's it. All right. So those were the Gen 3 things that I was trying to fix. Very successful so far. I'm very happy with it. Gen 2 is about to come apart, so I'm taking some video of it. Don't have a lot of pictures of it running last year. And that's sort of it. And let me see. And at some point, if somebody wants, I got a bunch of Python spaghetti code, but I built this box, 3D printed it. It looks like it bowed out from some sunlight hitting it over the summer. But this box is actually a monitor for me and then notifies me when things are out of whack. Right now it just shows you that it's yellow. That means it's a little bit high, but that's just because of where I set my thresholds. 100% homebrew, so I really like that monitor box. I have a V2 of this monitor box. I think I'm gonna have 4 probes. My goal would be to get a probe all the way down into the unit, onto that exhaust manifold, touching the metal, so I can get some real data from that. So that's future goal. I'm gonna pipe that, ship that right down the pipe to get there. So that's it for diesel heat. Let's see where we're at. We started at 50 this morning, 32 degrees outside, 50 degrees in the garage, and we're up to 59.5 degrees in about an hour or two. This thing can actually bring the temperatures up in my garage to be 60 degrees when it's 10 degrees out, which is pretty amazing. It just makes working in here so much better. And if you want more details on any components of this, let me know. I might make a quick short video just for you, just so that I can kind of explain what I did. All right, guys, have a great day. And that's what's inside the V-Tank's garage heat system.